Okay. Anyway, I want to, I don't see Keith here. I was going to thank him for everything he's been doing. Anyway, I got a list here of what you learned last week because I forgot what I talked about. So just to summarize real quick, starting kind of from the end, we discussed how on HF you can have different states. VFs are set at different dial. Like RTTY and AMTOR, a mark
a space frequency.
Over the radio, we transmit a change to indicate that a space is met. Okay. No change means a mark. So it's a change of state that conveys information. So whether you're both on lower sideband, or one's on lower and one's on upper,
which means you're,
because all you're looking for, all your TNC is looking for, change in state. This is all detailed out in about, I think it was about part 13 of the handout you got tonight, either the hard copy or the floppies. We're basically following what you have in the handouts there, so you might want to kind of find out where we are, and then you can read ahead if you want for next week or review what we've covered. The course. You'll be able to go right along with us. ASCII, we learned that
as long as the two units agree with each other. And the guy at the other end of your radio link can be whatever he wants because the X.25 in radios send to it from your terminal, and it sends the same format back to your terminal.
same thing at the other end.
So you may be even parity going into your TNC. Your TNC strips all that stuff off, takes those 7 bits rather, that represent the character, puts them into the X.25 frame, ships it to the other end. The other TNC says, okay, I get rid of the X.25 stuff around this character, and now I got to put odd parity or no parity or whatever, because that's how he has me optioned here at this end. Okay? So all you care about is how you option your terminal and your TNC. You don't care how the other guy is optioned. We talked about the connections required between the radio and the TNC, and it was pretty cut and dried. Usually it's audio from a speaker or a phone patch-out jack into the TNC. Audio from the TNC usually goes into the mic jack. Your push-to-talk lead is what controls everything. The only gotcha is there are certain radios where when you look at the schematic of the plug for your mic jack, it might say push-to-talk ground. If it does do that, then you got to be careful, because some radios have a circuit where you have what's called a push-to-talk ground that is not part of your regular ground that comes out to your mic or your TNC and back in. So taking a regular ground and feeding it back won't work in some cases. There are 1 or 2 devices that are that way. HTs, walkie-talkies, some of those are pretty weird. And the paperwork that we have back here will explain a lot of that to you. And then we talked briefly about what a TNC does. It's a protocol converter. It takes the ASCII protocol, strips the character information out, gets rid of start bits, stop bits, parities, puts it into the X.25 format, sends it to the other end, and vice versa. It's a speed converter. You may be running 300 baud into it, and it's 1200 baud out, and whatever. Okay? And then it's got a mailbox in it. You've got those 2 parameters, H-baud, T-baud. H-baud being the speed on the radio side, T-baud being the speed of the terminal. They don't have to match. Usually you would want your terminal to be at least as fast as the line, but it doesn't have to be. It can be a lot faster than the line. So that in a nutshell is what we talked about. Can you fire up the projector there? That's the switch, yeah. We were talking about RS-232 the other day. Now, RS-232 is a standard, and it's an electrical standard, not a physical standard. And this standard, and I'll define that in a minute, but this standard is what you find between the computer and the TNC, or if you're using a landline, the modem. This computer thinks the TNC is a modem, okay? So there is a definition or a standard so that all computers can talk to all modems, or all TNCs in our case. And like say, it's an electrical standard, not physical. You will normally see a cable with plugs that have this shape and have 25 pins in it. But that's not necessary. You'll sometimes see 9 pins in it. The standard defines what each of these leads does as far as functions and voltages and that sort of thing, but it doesn't define the connector. This is the most common configuration you'll see on the back of a computer and the back of a TNC. The other one is a 9-pin plug that looks about like that. Same shape, but only 9 pins. Have you ever seen any other ones? Sometimes you'll see a telephone line connector, a little modular jack that some use. That's a pretty simple interface. We have a message coming in. Okay, you can read that a bit.
It's gone over there.
Gone.
When you touch the cord, the screen went out up here. I don't know what happened.
Yeah, down here.
Well, I notice this thing flickering every once in a while.
Back to the PC.
Anyway, while our ace troubleshooter goes to work again,
That's the one.
the 3 leads that are very important to every installation are the ones called frame ground. That's what FG is, frame ground. Send data, receive data. Send data is the ASCII characters. Remember we talked about last week on RS-232 you have pulses that are between +3 and +25 volts and -3 and -25 volts. That's what rides these leads. This is in the direction from the TNC, from the computer to the TNC, or modem. So this is our TNC. I'm backwards again. This is the computer. This is the TNC or the modem. And by convention, your TNC or your modem will have a socket. This is the connector with the holes, the female. By convention, the computer on the back of it will have a plug or a male. Quite often you'll see a designation called DTE and DCE. DCE means data communications equipment. DTE means data terminal equipment. That's a telephony data term.
So the computer pins are always male, and the modem pins are always female.
Most of the time. I'm sure there's probably exceptions, isn't there?
Yeah.
Like everything else. But that is the convention. It's not the law. Remember, RS-232 is not physical. It's electrical characteristics. But that's the normal convention. As far as modems go, I would say that's probably 100%. I've never come across one that wasn't.
No,
TNCs may vary. The people that build the TNC don't realize this.
yeah, as a matter of fact, that TNC, oh, okay, yeah, that TNC, which is a DCE, and I think just about every TNC has the male, or a female.
Yeah.
I don't know.
Generally, that's it. So anytime you have a cable, you know you're going to have a male and a female at each end. Anyway, when you type away on your computer, what you're typing goes on the send data lead into the TNC. Anything comes in on the radio comes back on RD, receive data, into the computer. Now those are the most commonly used leads, but we're going to cover the other ones here real quick, like, because sometimes you got to play games. We had to do it with this one and one of the other ones the other day when we had to do a loop. You have a lead coming from the computer or terminal called request to send. And you have a lead, pin 5, coming back from the TNC or the modem, if you're using a modem, called clear to send. Basically the way that works is you type away, your computer says to the TNC, can I send? The TNC says, well, I'm not in a test mode, I'm in a normal mode, I'm ready, yeah, go ahead. So it turns on clear to send back. Now I really don't know of a TNC that requires this, but there are some computers or terminals, I've got one at home, that turns on request to send and expects to see a clear to send back before it will allow the data to go out. So when I hooked it up and I typed away, nothing happened. So I had to put a little strap from 4 to 5 so that every time the computer said, can I send, it came right back to himself. He didn't know where it came from. And said, sure, go ahead. So it was automatic. Every time he asked, he got an answer. He was happy. So as far as TNCs, you don't have to worry about those leads normally. But as far as terminals, computers, you may. Wasn't that the problem with this, or was he looking for carrier?
He was looking for carrier.
Carrier, okay, that's the next one.
For carrier off, but that's because we got a defective ports card.
Oh, okay. We have a lead down here at the bottom, pin 8, called DCD, Data Carrier Detect. Now, some terminals require that before they will let the data coming in go to the screen. This lead is the modem or TNC's way of saying, I have a valid data carrier coming in, so what I'm giving you here on pin 3, received data, should be valid. Go ahead and decode it. Some terminals require that. This one here, would this normally have done it, or was that the bad ports card, or was it just backwards?
What?
The carrier detect was... Does it require it now?
No.
No, okay, that was a bad card. Anyway, some devices require this lead to be high or on before it says what I see coming in here from the modem TNC is valid. You have another lead here, pin 20, going to the TNC, called Data Terminal Ready. By convention in RS-232, anytime I turn on my computer or my terminal and I'm online, in other words, I'm not in the test mode, I'm not booting up, I'm ready, the terminal or computer turns on pin 20 to the modem to say, I am here. For example, if you have a modem on the landline and somebody calls you, your modem will not answer unless this lead is on into the modem or is strapped on inside the modem. That lead tells the modem that this terminal is ready. Go ahead and answer. Now, as far as TNCs, we don't use it. But where it is handy is, anytime a terminal or computer is on, they all have pin 20 to my knowledge. You can take pin 20 and feed it back to carrier detect, feed it back to data set ready, so that the terminal is always happy. Data set ready is kind of the equivalent of data terminal ready. It's telling the terminal that your modem or your TNC is ready. So what it boils down to in a nutshell is you're only going to normally use these 3 leads for your TNC. I always like to use pin 7 also because that's called signal ground. You got signal ground and frame ground. I like to use them both. In fact, if you're going to admit one, I would say you'd admit pin 1. You'd want to go 2, 3, and 7 as an absolute minimum. Because that is your reference for these 2 leads here, the send data and the receive data. Frame ground is more of like a shield and that sort of thing.
Is it important, like in electrical, to be sure to have that hooked up?
Frame ground?
Lightning. I said electric, I meant lightning.
Not really at this point, because if lightning gets to this point, you're in deep trouble. Because you got the phone line, I mean the radio antenna, and the power coming in. If lightning gets to this point, yeah, you're in trouble. So anyway, like I say, pins 2, 3, and 7 are the absolute minimum for a TNC. And for most TNCs, that's all you need. You may have to play games by taking pin 20 and feeding it back to pin 8 and to pin 6 if your terminal or computer is looking for a high on those lines before it will decode the data. You may have to take 4 and feed it back to 5 in order for your terminal to send out data. So remember, if you can't seem to send, this could be the problem here. If you can't receive, then this could be the problem here, where you need a high here on 8 and a high here on 6. Now, where a lot of people use pin 8 is a lot of TNCs have a parameter called DCD on, carrier detect on. What that does is tells the TNC anytime anybody connects to you, turn pin 8 on. Then you take a little 555 and you put a little son alert on it, and you have a connect alarm. Somebody connects to you, that lead goes on, your son alarm goes off for 30 seconds or beeps or however you want it. And your wife gets tired of hearing it and divorces you. But that's a way to know when people have connected to you remotely. The only other thing keep in mind is, by convention, this cable should never be longer than 50 feet. If you got a nice low cap cable, you can go more than 50 feet. So if your terminal is up in the second floor bedroom and the station's in the basement, you might want to be careful. Another thing to keep in mind, somebody else is here tonight, never use a cable that has leads that are not used because they become antennas. Let's say, for example, your computer doesn't have 4 and 5. So you have a cable here with these leads floating, and these leads happen to be hooked to something in the TNC, and you start keying up, you got antennas hanging out here, and it starts introducing garbage. I had a situation when I first went on 20 meters where I'd be typing away, and the guy kept saying, you got these little curlicues interspersed in your data. I said, well, that stuff's supposed to be error-free. I don't know how it's getting in there. Well, what it was is every time the transmitter would key up while I was typing, noise would get introduced in here. It always came up as curlicues. And it would get interspersed with the characters coming down here. The TNC looked at my data, looked at the garbage, said, well, that's what's coming in. He did all his mathematical stuff, shipped the packet out. We're going to get into this a little later on. But anyway, shipped the packet out. The TNC at the other end looked at it and says, okay, I got this error-free. That garbage is garbage, but it's just like it was at the other end. It hasn't been changed, so it's error-free garbage. And it puts it up on the screen.
What do you do with those empty sockets?
Cut the wires. Yeah, you just don't want the leads hanging. If you're going to use a lead in the cable, you want to make sure there's a circuit in here that's hooked to that pin and a circuit in here hooked to that pin, particularly on HF. Yeah, you should disconnect both ends of the wire.
You get these commercial cables, they've got all 25 pins connected in there.
Right.
You go buy them at Bismarck or whatever.
That's true, so you got to go in there and cut them out. Most of your TNC manual, pardon me?
Might be better to make your own with only 5 or 6.
Well, you only got a couple of wires, so I do. If you're running HF, then I would advise you to get shielded cable. VHF isn't too bad on packet, but I tell people that HF and packet are like husband and wife. They get along sometimes.
Hey, Bill, would that ground on number 1 take care of part of that shield?
It should, if it's intertied, but you got to be careful. The PK232, for example, doesn't have the shield tied to the internal ground. When I first ran HF packet in my car, I typed in some characters and hit the return key, and everything in my car locked up. The terminal, the PC, the TNC and all that, and that's when I found out that this ground was floating. Okay.
If you connected all the unused wires to a good hard ground, it wouldn't hurt anything, would it?
Probably wouldn't. The recommendations always say don't have any unused cables. If they're connected to ground at both ends, I would assume that it wouldn't hurt anything because you do have a termination on each end. The only thing is, if you've got a fair length of cable, then you got to remember a ground is not a ground at RF. Yeah, you know, and because I mean, if your cable pair happens to be exact, say a quarter wave or a half wave, it becomes resonant. I mean, years ago, I used to load up my radiator in an apartment. I was on the 3rd floor because I mean, you know, ground is not a ground to RF, and it worked well. I'm sure TV sets were going nuts in various places, but nobody knew who I was. Okay, any more questions on that? Woody?
When you were running mobile packet, did you find it was appropriate to tie the frame ground lead to the chassis of the car?
Okay, the question is, if you're running packet mobile, should you tie the frame ground lead to the chassis of the car? It really depends. In my case, it didn't really help. I had to actually go in and put isolation on the RF side of the TNC. I had to actually use transformers and then a relay on the push to talk to eliminate the ground even being connected to this, because you probably heard about different types of grounds and ground loops. What you want is basically a, I think they call it a star, where you have all this stuff and they all tie to a common ground. Okay? And then you don't get the ground loops, where if you have this piece of equipment tied to ground, going over here, and then this piece of equipment tied to this, and then to ground, so it's kind of floating out here. Again, by the time this piece of equipment sees the ground, it's not a ground to RF. In my case, it didn't help. I tried grounding the case of the TNC. It just changed it a little bit, and that sort of thing. When you're running HF packet mobile, and you consider you're sitting inside your antenna, computers go nuts, TNCs go nuts, and sometimes your electronics go nuts. I have a kit made up where I can get my HF rig into a rental car within about 15 minutes, if not sooner, and that's with coax not hanging out windows or anything. You know, I've gotten very experienced at this. And I've run into strange things. I had one Japanese car, every time the packet would go out, the dashboard would start speaking Japanese. That drove me nuts. And of course, I've been through the thing where you key it when nobody's around you because you don't know whether you're going to take off like a rocket or have your brakes slam on, you know, and all these kinds of things. Okay, from there, next slide. Now we're going to start getting into this week and next week are going to be a little heavy. That's why we're going to give it to Joe here shortly. He can be the heavy. We're going to talk about the protocol. And you really have to understand the protocol so that when we explain how to use nodes and how to use digis and why you use them this way, you'll understand it. And particularly when you turn on the monitor to see why things are or are not happening, and you see all these frames, you'll know what they are. So that's why we cover this stuff, so that you can actually analyze what's happening. Otherwise, it's kind of like driving a car. You drive the car, and you go out one morning and it doesn't start, and you don't understand how it works, then you don't know how to get around the problem. But if you know how fuel injection works, or if you know how a standard carburetor works, then you don't have to pay AAA to come out 2 days after it's 10 degrees and haul your car in and you know, jump it for you and all that. We have 3 basic types of frames, 3 categories, and then under these categories, we've got more categories. We have, starting at the bottom, information frames. When you're typing away and you hit the carriage return or several other things happen, you get a frame that goes out that contains your information. Okay? You have supervisory frames, and basically these frames are used to control the link, to tell the person that, or the TNC that sent you an information frame that you got it error-free, okay, to inquire of the other end, what status are you in? Are you ready for more data? So it's kind of used for link control, because you just can't sit there and just blast information out and then hope it gets there. So the supervisory frames allow control of that, flow control. Let's say that when we were connected to the tanker, we were sending data real fast, and he was using his TNC to do some other stuff, and for a minute he didn't have any room for the data. It would use supervisory frames to tell us, hey, keep it in here, don't send it yet. And then when he's ready, his buffer, he gets rid of some of the data in his buffer and he's got room, then he will send a supervisory frame to tell us, okay, resume sending, I got a place to put it. You can report such things as errors in the way the frames come in. I could send 5 frames out, and maybe one in the middle didn't come through, got lost. So he got the first 2 and the last 2, but didn't get the one in the middle. It supervises the link. Unnumbered. These are the frames that are used to set up a connect to a station and to drop a link to a station. And we're going to go through all this in detail. So the unnumbered frames are used for setup, teardown. It's used to define a status. It's used to report protocol errors. And one of the things it's used for that's very unique is roundtables. In other words, we've been talking about how I set up a link to you and we sit there and talk. Well, that's great, but what if I want to have a roundtable, 5 people? How do we do that? Because remember I said I could set up a link to you, and I could set up a link to you, and I could set up a link to you, and I could send to you and send to you and send to you, but you two wouldn't know what we're doing, and vice versa, unless you turn your monitors on, and then it's a mess trying to read all this stuff. So there's what's called an unnumbered frame that allows me to send out a packet and you will all see it, and vice versa. There are some problems with this because it's still an error-free mode. And if the wife happens to fire up the vacuum cleaner just as I send that packet to you, you may not see it because it got corrupted, but you two will. So that's one of the pitfalls. But there's a way around that too, called the garbage mode. Okay, any questions? Do I see him? Any questions on the 3 types? Okay, let's go ahead and start talking about the unnumbered frames.
I have a question.
Oh.
You say that the supervisory is to inquire as to status, and the unnumbered is to define status. I'm a little confused about that.
Okay, well, without getting too deep into it, this is the main vehicle for defining things like asking what is your status at the other end, and returning status information. It's a way of indicating to the other end that you're busy or you cannot accept data for a while. And then later on, it's used to say you can accept data. The unnumbered So I'm trying to remember the example of using an unnumbered for a protocol error.
Is that like transparent mode?
No. It's a mode where you're not requiring an ACK or a response, where you just send the information out. Why don't we do this? Keep that question in mind, and as we go through the actual frames, ask Joe, because he's going to be talking. I know there's a case where an unnumbered frame is used, but I can't remember the specifics on it, for protocol. Normally it's receiver, or I won't say receiver readies, but supervisory frames that do this. Oh, I know what it is. It's the FRMR.
Oh.
That's what it is. I'm going to talk about it in a minute. I just looked at my book. Oh, yeah, okay. Okay, if we can go to the next one. Okay, here are our basic unnumbered frames. And what we're going to do is just kind of give an overview of all the different frames. And then we're going to look at a couple of the fields in the frames. And then Joe is going to give you specific examples on the screen. And then from there, we hope to do it over here. The first unnumbered frame is called a SABM. Set asynchronous balance mode. Don't worry about that. When I say connect to W6ABC, my TNC sends out a SABM. It's a connect request. If W6ABC is there and he wants to accept a connect, he sends out a UA, unnumbered acknowledgement, that says, I acknowledge you, I'm ready. So here's what happens. I say connect to W6ABC, that goes out, W6ABC receives it, his connect light turns on, then he sends a UA back to me, my TNC sees it, unnumbered acknowledgement, my connect light goes on, my screen says connected to W6ABC. Now here's an example of what I mean by understanding the protocol. I sit here and I type connect to W6ABC, SABM goes out, W6ABC sees it, his connect light comes on, his message says connected to W6OAV, and he sits there and types, hi Bill, how's things going? And nothing happens. The reason for it is he sends a UA to me, but I can't hear him. He's very weak, he's in the noise, but he hears me. My TNC, after a period of time, resends this. He sends it back, but I don't hear it. So as far as I'm concerned, we are not connected. As far as W6ABC is, we are connected, and he's going, you know. And then he does like the typical packeteer list. He gets on the phone and calls me and says, what's going on? We got to use the phone to make the packet work, right?
Right.
But this is one of the examples of, if you understand the protocol, you can analyze a lot of problems. And that's why we're going into this mess. Okay, we got another frame called disconnect mode. This is where I may be connected to somebody, and for some reason, his TNC determines that I've gone away. And I won't go into why right now, we'll cover that later, but his TNC decides that we've lost the connection, and he goes to the standby or unconnected mode. My TNC sends some information to him, because we'd been typing, and he will send a disconnected mode or DM packet back saying, hey, we're disconnected, what are you doing? And my TNC will say, oh, okay, and I'll disconnect. Or, remember the other class I was talking about how you set users to 1 or 2 or 3 depending upon how many people you want to connect to you? Okay, let's say I am sitting here and I have users set to 1 and I am on logical channel 0 or stream A depending upon your TNC. I'm on that first channel and the W6 ABC tries to connect to me. My TNC will say, oh, I cannot accept his SABM and send a UA because he's only got that first channel available and he's on it. I will send a DM back, disconnected mode. That tells W6ABC he's busy, he doesn't want to talk to you, and it will say W6OAV busy. The DM back to him tells him that I am busy. I don't know if you can see it on the screen still. Up the top it says connect request WG0N. He sent us a SABM, but we had users set to 1, so he got a DM back from us saying, what's the call you got here, KE0QA? -1. KE0QA-1 busy, and our screen says connect request WG0N. So we know he tried. And I can turn around and go to my next channel if I want to talk to him and say connect space WG0N and set up a link, because users only affects incoming not outgoing. I can run 10 of them out even though I got it set for one in. You'll see a lot of these DMs flying around because a lot of people only run one user because they don't know how to multi-connect. So that's what it is. It's nothing personal when you get a busy back from the other station. Disconnect. Just like it sounds. I'm sitting there typing with W6ABC, and we're all done. I go to the command mode, which Joe will show you. It's fun volunteering you for this stuff. And then I'm going to sit over there. So I go to command mode and I say disconnect. My TNC will send a disconnect frame out. The other one says, okay, sends a UA back. So again, when my disconnect goes out to W6ABC, his connect light turns off, his screen says disconnected from by W6OAV. He sends a UA back to me. That turns out my connect light says disconnected from W6ABC, and I go back to the ready mode.
So then the difference between disconnect mode and disconnect is that disconnect mode is used when you were already disconnected.
Right. This says I'm in a disconnected mode. You can't send me information frames, we're not connected. Or if you're trying to connect to me, initially, that says, I don't want to talk to you, I'm busy. As far as you're concerned, I'm disconnected from you. I won't let you connect to me.
One's a command and one's a response.
Yeah, I was trying not to get into that right now until you kind of show it on the graph, but yes. Another thing, don't forget that now.
That was set asynchronous. What was the rest of it?
Set asynchronous balanced mode, I believe. I wrote that down here because I knew I'd forget. Set asynchronous balanced mode. That comes from the real X.25 protocol. That's a carryover from that, and it has a lot of meaning over there, but for over here, let's not worry about it. And then, in answer to your question, we have this FRMR. It's a frame reject, and it's called an unnumbered frame with a special mission. And what that is let's say that a frame comes into me being my TNC, and the algorithm indicates there are no errors in this frame. I got it the way it was sent, but it's not structured right. Maybe it's a special type of frame and it's got too many characters in it. For example, a information frame, I think the maximum character count is 128
I believe so.
bits of information in an information frame, and let's say it's got 130. Then I'm going to send this back to the other end saying, it got here error-free, it had the right number on it that Joe's going to talk about, but it violates the protocol rules. You can't have 130 characters in there. There's something wrong. It's error-free, but something wrong. It's a frame that has an invalid sequence number that Joe's going to talk about. In other words, everything's there, but it's just the inside of the frame is not right. It's about what it amounts to. Or it's an invalid command. You're telling me to do something that I can't do. I've generated a lot of FRMRs. I have a problem always remembering that. When I've connected to a system using two different paths, and there's a thing called an SSID that we'll look at in a minute, which is a little number tacked to the end of your call. And it just so happened the way these two paths came in, because I went two different ways through the network to get to this one node, I came in with the same call and same little number on the end of the call called an SSID that we'll talk about. And the system just went barf because all of a sudden, here comes a packet in with a number on it. Remember how I talked about numbering the envelopes so that you knew they got there? Well, here came envelope 1 and envelope 2, and then all of a sudden, here comes envelope 1 again. But it's different because it's on this other route. But it's the same call. He thinks it's me. And then he just goes nuts. And he sends this frame back with special hex information in there that if you want to go get out a book, you could decode what he's telling you. Most of the time you just disconnect everything and say, heck with it, go do something else, you know, but you can analyze this frame to find out what he's telling you.
So the actual word that FRMR stands for is?
What does it exactly stand for?
I don't know, frame reject, I always call it.
Yeah, frame reject. FRM for frame and R for reject. That's what my note here means. Okay, that's an overview of these commands and responses. Any questions on these before we go to the next one? Keep in mind, Joe's going to get very detailed in them here shortly.
UI means?
Unnumbered information frame.
You had a little scenario at the beginning with when you sent a SABM message and that turned on the connect light for the other person.
Mm-hmm.
And they sent the UA and that turned on your connect light.
Right.
And then you were saying something like, I don't remember, either you could hear them or they could hear you, or anyway, something wasn't getting through. The connect light was still on, but the message wasn't getting through, is that right?
Yeah, what it is the question is the scenario we talked about a bit ago where one person thinks he's connected and the other person doesn't. If I'm sitting here and I type connect to W6ABC and I'm running 100 watts, my SABM goes out to his TNC, he hears it, he turns on the TNC there turns on the connect light, says connected to W6OAV, and sends a unnumbered acknowledgement back to me. Only he's running 1 watt and I don't hear it.
But your light still goes on.
My light's off.
Your light's
I haven't gotten a response from him.
Oh,
So then I resend this again. He resends that. Well, in the meantime, W6ABC sees that he's connected to W6OAV, his connects light on, so he's typing away. And he's watching. There's a light on the TNC that tells you when the message goes out and has been acknowledged by the far end, and we'll go into that later on. And that light never goes out. So then he calls me on the telephone. And I say, well, I'm not hearing you. I'm not connected to you. And he said, well, yes, you are. My light's on. I said, but mine's not. Because it takes a response from him to tell my TNC that he is there.
This happened one time when we were connected and I had a power glitch. I went completely bonkers. I had nothing, dead terminal, everything. Come back on a second later, I was not connected. But he says we were. He lies to me. That's when I get on the telephone and say, hey, your machine ain't working.
Right.
It was.
Question?
Well, I'm a little confused. It would seem to me with all this communications back and forth between the two stations that there would be something in there that would tell, would tell both of them that they're not, that he's not, you're connected to him, but he's not connected to you. But what you're saying here is that doesn't happen. You can be connected to him, but he's not connected to you, and you're not going to know it until you're trying to send a message and it doesn't go anywhere.
Yeah, what'll happen is I or my TNC will send this connect request X number of times. It's a parameter in the TNC called retry. How many times do you want to try something? And then at the end of that, you send out a disconnect because maybe the other end's hearing you, but you don't know it, which happens to be our example. And that will disconnect him, put him back in the idle mode. That's when he's going to know. W6ABC is going to know that he never got through because the STA light sat there, which is the light that says that your data is in the buffer waiting to go out. And it sees this transmitter coming up, and then all of a sudden it says disconnected by W6OAV. See? Because W6OAV gave up and said, I'm going to disconnect you. But having been to this packet class, W6ABC turns on his monitor and he sees that his UA is going out, but he sees these coming in. He says, oh, okay, he's not hearing me. See, that's the whole point of going through the protocol, because when you turn on your monitor where you can see the packets themselves, you can figure out what's going on very easily. And that's the whole point. If you don't understand the protocol, then this stuff doesn't make sense. Once you understand it, you can pretty well analyze about everything that goes on. Okay?
You mentioned before frame had 128 characters. Is that
constant or a variable? Or
No, that's a variable, and about 2 slides from now we're going to get into that. It is a variable, because you do want to vary it depending upon whether you're on HF or VHF. And we'll talk about why.
When you monitor what's happening, is that when you turn on the MCOM?
Yes, MCON or monitor.
Okay, no, MCOM.
Right.
And
MCOM is...
that's the little bracket information at the end of the line that like
Mhm.
is RR and then it's
Yeah,
and then
exactly.
a bunch of other
And you're going to see it on the screen here, and you're going to see it over there shortly. But it's become a data scope. You're actually seeing the structure of the packet itself and what it is, and this sort of thing. So that's how I knew I was sending out garbage, that I was really sending this stuff out. I turned on my monitor and had it go through another station where I could watch it, and sure enough, I was sending out curlicues. And if I move the cable around, I'd get more curlicues, and move it here, and I'd get less curlicues. So I knew right away what the problem was.
You can turn on MCON and watch other stations.
Right, exactly.
MCON.
You can help other people if they don't understand. You can turn on your monitor and you can explain to them what you're seeing and tell them what the problem is and all that. And Joe's going to cover all that. You got 10 minutes now, you know. So yeah, you'll be able to help other people as well as yourself once you understand the protocol. Any other comments on this slide? Okay, we'll do one more and then we'll take a break. Supervisory. We have what's called a receiver ready and a receiver not ready. Almost self-explanatory. And here's one you can't let get you down. It's nothing personal, but you get rejected when you get one of those. It's a reject frame. Now I think you'll see where the flow control comes in here and link control when we explain these. A receiver ready says, I am ready. And it's also a way of acknowledging. So W6OAV sends a frame of information to W6ABC. W6ABC gets it error-free. He sends a receiver ready back telling me that he got it error-free, and I can send the next frame or frames of information. Now again, Joe's going to give a good graphic example of this. This is an overview, so if you don't really understand it, this is just to kind of get you primed for Joe's entry here. Receiver not ready. That's the form of flow control. If you're sending stuff to me and my buffer is filling, and let's say, remember I said that your speed of your terminal should be equal to or faster than your TNC. Let's say data is coming in at 1200, HBAUD is 1200, and I got T-baud, or the speed between my terminal and my TNC set at 150 baud. Much slower. Well, then the TNC's getting all this data and it's got to buffer it while sending it slower here. Eventually the buffer fills. Then he says, receiver not ready. Stop. And then my buffer sits here. Eventually, the other end will send a receiver ready saying, are you ready now? Remember I said receiver readies or supervisory frames are used to request status. I would send a receiver not ready saying, not yet. A certain amount of time would go by. It's a TNC parameter setting. Pretty soon the far end will say, are you ready now? I would send a receiver ready back saying, yeah, I'm now ready, let it rip. You get the idea what we're talking about here?
So receiver ready may be an inquiry or it may be a response.
It may be a command or a response. When I want to know how you are doing, I say receiver ready, and there's a special bit called the P bit that Joe's going to explain. Or maybe I will. I might be in that part of it yet. Maybe I'll have to do that one. But anyway, I demand, with this special bit, a command, I demand you answer me. And you're going to come back with either one of these with a special bit that's called an F bit saying, this is my response. So you have commands and response, and depending upon who's talking to who, either one can issue a command. There's not a slave and a master. Okay? It's just like my TNC could send several frames of data to the far end and then demand that the other end tell me whether he got them or not before I go any further. And then he would come back with a response. we got the reject here. What that is let's say that I send 5 frames of data out. And I say this is frame 0. Remember the envelope thing we talked about in the beginning? This is frame 0. This is frame 1. This is frame 2. Okay? And let's say frame 0 comes in. And then as frame 1 is coming into the receiving end, the XY upstairs fires up the mixer, and that wipes out frame 1. And then frame 2 comes in and frame 3 comes in because it was a fast mixer job. He's going to send a reject saying, I missed a frame. I got 1, 3, 4. So I'm throwing 3 and 4 away. I can't keep them in my buffer. That's one of the bad things of this protocol. When I receive frames, they have to be in sequence, and anything that's out of sequence, I get rid of. So the other end's got to send them all over from wherever the reject was all the way up again. So you have to send 3, 4, and 5, even though 4 and 5 got there originally. There are some new versions of protocols coming out that get around that, and they also do error, not only error detection, which this protocol does, it does error correction. It will actually correct the error. It'll figure out what it should have been. So there's neat stuff coming down the pipe. One of the other things, well, before I get into that, any questions on these? Okay. One other thing I was going to mention, I didn't mention in the first class when I talked about what you can do on Packet, but there's a satellite network coming into place. And last night, I went through WG0N to 18 megahertz, went to Germantown, Wisconsin, went over the 2-meter system, went through a bunch of nodes, 3 different frequencies, 2 meters, 220, 450, got to a conference bridge that's tied on what they call internet, satellites, and then from there was talking to a guy in Australia, a guy in New Zealand, that sort of thing via satellites called wormholes. And I guess there's a possibility that we may have one here in Colorado Springs. You just take one node hop down and you can work the world. So that's one of the things I forgot to mention. The HF is very slow right now. It's 300 baud, static, fade, and all that. But this satellite network is starting to come into play. And it's going to be incredible when that comes in, because the other thing I did is I went and picked up a wormhole, went out to California, and then worked a guy there. And it was just like today, a guy was telling me, well, in order to get to Illinois, I had to go to California, pick up the satellite, and then go to Illinois because I couldn't go direct.
Are those Oscar?
No.
Amateur satellites?
No, these are satellites, commercial links that some clubs go together and pay for. A lot of businesses, and I think that's where ours is going to come into play here, a lot of businesses have satellite links that they use for testing and whatever. We had one out in California, and they just said, sure, anytime we're not using it, it will be available to you hams. And this sort of thing. I know there's one going in Tennessee right now. It's going to Brussels, Belgium. It's some company there that has an office in Belgium and one here, and they got capacity. So they said, yeah, because there's only one voice channel. Go ahead, you guys. A couple of hams work there. Of course, that helps. Go ahead and put it up there and use it. And the guy's saying, you know, it's pretty wild. He says, I have a hard time going 100 miles, but I can talk to Belgium like they're sitting in the next room. So there's a lot of neat things coming down the pipe. Les?
I was just going to ask you to meet what is a wormhole.
Oh, I thought I defined that. Okay, a wormhole. Well, when we get in the network, we'll really define it. But a wormhole is a satellite link.
It's where you go into the commercial service and come back out into the amateur service, basically.
Well, there are some that operate on ham satellites, but those are intermittent because they're moving. They're not stationary. A wormhole can be a phone line. We had a wormhole in California. Had 2 wormholes that were actually dedicated phone lines. Pardon me?
It's out of the amateur band and comes back in.
Yeah, other than the intermittent Oscars. See, the Oscars aren't suitable for this because they're not in range long enough. And that's the only reason. But there are some that use Oscar when it's in range. And there are Oscar gateways going in. So a wormhole can be either one. Normally it's commercial right now because the amateurs don't have anything that provides 24-hour service.
How did you define it?
A wormhole? Okay, a wormhole is what you might call a long-haul hop. It can be a phone line, a satellite link, that sort of thing. And what the idea is you've got this network, like we have one here in Denver, or in Colorado, and you got nodes that you hop along, and maybe a gateway where you might hop to some other area, and then all of a sudden you drop into this hole like a wormhole, and you come out way over there somewhere, and it's always there. That wormhole is always there. That's kind of where the analogy came from. When we talk about the network, we're going to show you all this stuff. We're getting ahead of ourselves here. If there are no questions, by the way, let me read this. Hi, Joe, and hello to the class. This is from Dave. He's the sysop of WG0N-7. He is WG0N-0. Just a bit of information. When you are leaving your message to the SS Coastal Eagle Point oil tanker, W18W came up about 100 hertz at 30 over S9. Okay. Let's see. Okay, he says, tell this to the class. He said, this is Sysop Dave, WG0N-7, K node near West Jewel and South Union on the south flank of Green Mountain, elevation 5,800 feet. Over. Of course, we never answered him because we've been busy. Notice the K. It's kind of like CW. You usually use a K or some symbol to indicate to the other end, go ahead. And there's reason for this that we'll get into when we demonstrate this stuff. Oh, a little bit of culture. Mark Twain once said, suppose you were an idiot. And suppose you were a member of Congress. But I repeat myself. I put one in this upcoming issue of Roundtable. Remember we talked about that one parameter where you sit there and you try to get something through, and if you can't get it through, then you quit after a certain number of retries. You know, there's a parameter in your TNC called retry. And you can say that my TNC will try it 5 times and then give up, or 10 times, or whatever. So the latest saying of the DRC Packet group is, old packeteers never die, they just retry out. And with that, we'll take a coffee break. Packets. The top frame represents all the different frames we talked about. Receiver readies, receiver not readies, everything except for the information frames. This is the information frame. See, we got an information field. So, when we're sending a receiver ready or a receiver not ready, that sort of thing, we take the beginning of the frame and we put what's called a flag at the beginning and the end. That's a specific bit pattern structure that tells the receiving TNC when to start looking at the bits and when to stop looking at the bits. Remember in the ASCII character we had a start bit and a stop bit? Now we have start bits and stop bits. This is what they call a bit protocol. Once I see the flag, I know I'm going to have an address field that contains 14 to 21 octets. An octet is 8 bits, also a byte. I guess they're pretty well the same, aren't they, Joe? Is there any significance to an octet as opposed to a byte, other than IBM or somebody wanted to call an octet? It's 8 bits of information. We're going to look inside these fields in a minute. Right now, we're just looking at the overall structure. So anyway, we'll have a flag sequence here that alerts the TNC to start looking at these bits. It knows that the first 14 to 21 octets, or groups of 8 bits, is going to be the to address, the from address, and the via address if it goes via somebody else. Remember we talked about on the envelope, you put a to address and a from address? That's where it goes, right in there. We have one octet, these 8 bits right in here, that tell the TNC, what is this frame? Is it a receiver ready? Is it a receiver not ready? Is it a reject? What is this frame? Is it a disconnect? That's how he knows what it is. Then we have the FCS, frame check sequence. Now this is where the magic comes in. When the TNC sends this frame, it looks at the bit structure in here. Between flags, Joe? Is that right? I don't think flags are included in that. No, they wouldn't be because it's after it. Okay, so it looks at the 1s and 0s in here, the bit structure. Basically what it does, it derives this hairy polynomial based on where the 1s and 0s in here. You know, 10x to the 23rd plus 9x to the 22nd, and depending upon the bit structure, it assigns values to this polynomial. But it comes up with a polynomial that derives from this bit structure, from here to here, actually. In this case down here, from here to here. Then it takes a universally known polynomial, small polynomial that everybody knows, and it divides this known polynomial into the derived polynomial and comes up with a remainder. Not an answer, but a remainder. It sticks the remainder in here in these 2 octets. Okay, so he derives a polynomial based on positions of 1s and 0s, takes a known, universally known polynomial, divides it into this derived polynomial, and puts the remainder in here. Ships it out to the other end. The other end does the same thing. If he gets the same remainder, he says, it was error-free. If a couple of these bits got changed in here, then the receiving end derives a different polynomial, because the bit structure is different, divides it by the known, universally known, everybody knows it, and he comes up with a different remainder. He says, uh-oh, there's errors in there. So I'm going to throw this away, because I don't even know if the address is correct. Maybe that's not me. It came in here, it said W6OAV up here in the to address. But since I know there's errors in here somewhere, maybe that was W0OAV, or whatever. So he throws it away. If there's an error in that frame, he throws it away. Like I say, the algorithm that he performs here is so good that you could be sending these things 24 hours a day, 7 days a week, theoretically, for 3,000 years, and maybe you might accept one frame that had an error in it. You might miss one. That's awfully good.
The algorithm does not include the FCS?
No. Doesn't include the flags. Because, see, if the flag has an error in it, he's not even going to look at it anyway.
saying, but it does not include the FCS.
No. He drives the polynomial on this information here, or this information through here, and then puts the remainder into that slot. If you get an error in this FCS, well then it's not going to compute anyway. So you have error protection right there, because if that gets errored out, it's going to come up with a different answer. If that gets errored out, he's not going to come up with what's in here. So you've got self-protection, so to speak, in there.
The term FCS means?
Frame check sequence is what FCS stands for.
Is this AX25?
Yes. Level 2, if you know what level 2 is. Joe may talk level 2 and level 3, I don't know. But yes, this is level 2 of AX.25. If you're familiar with X.25, the basic difference is we can put more addresses up here than you can in commercial X.25. And we have that unnumbered information frame for roundtables that we talked about that X.25 doesn't have. I saw another hand somewhere out here.
Is the top box, are we looking at unnumbered?
This is everything except for information frames.
This is the top boxes if it's making connects or whatever?
Yes, This is everything except for the info frames and the unnumbered information frames. That's all the other ones. You'll see a better idea of what's going on when we look inside these in just a minute. The only difference here between these two is the fact that we have an information field that we don't have here. In other words, if I want to send a receiver ready, a receiver not ready, or a reject, all that is contained right in here. In other words, who's it to, who's it from, how did it get there, via some digi or some digital repeater. And this in here is going to say receiver ready, receiver not ready, da-da-da-da-da-da. And there are some sequence numbers contained in here too that Joe will talk about. So the only thing different is down here we have an information frame stuck in at this point here. And we have sequence numbers in here, the fact that this is an information frame so it knows to look for information, that sort of thing. Any questions on this?
So the information that tells exactly what that unnumbered frame wants or is asking is contained just in the control?
In the control field. Mm-hmm. Slide after next, we're going to look into there so you can see what's in there. We're going to look at this one next. Okay? Any questions on these?
The little dotted line and the PID variable under the information?
That, when we look into the frame a couple of slides from now, we'll see it. That's a special bit that's set so that the information contained in here will be used by the node as opposed to the user. That's a special bit that we'll talk about. You will never generate one. If you do, you'll have some sysop somewhere calling you up saying, K0YUM, when he first put on his computer, had that bit set, and he loaded all kinds of information into the nodes. And we had just put on W0TX our gateway, and they called me, accusing me of corrupting the network. And I go, we don't have that bit. And I went in and turned on my monitor, and it wasn't set. And I happened to see Fred come up, and that was set. And all his user information was going into the routing tables, and so these nodes were trying to set up links to China and whatever. There had to be a call, and it looked very similar to TX, and that's why we got blamed for it. Okay. There are times when you might want to see these frames even though there's some errors in them. We had a problem here about 2 weeks ago where we had packet coming out on our 10-meter repeater, which is not exactly good. And we didn't know who it was. And what was happening is it was coming in on the link. We have a UHF link that connects the 10-meter receiver with the 10-meter transmitter because you can't have them at the same site. Cavities are too big and expensive for 10 meters. So you separate them physically. It's a UHF link, and there was a station, most of us couldn't hear it, but it was coming into the link and out on the 10-meter transmitter. So because it was a spur and not clean, there was always errors in it. So we went to the TNC and we turned on Pass All. Pass All says to your TNC, I don't care whether it's error-free or not, put it on the screen. And we would see garbage in here, but we saw the from address most of the time, and we knew who it was. And we called them up and said, do you realize that your call is going out on 29.62? And that caused immediate panic. So there is a junk mode called Pass All when you want to see things that are, in errored mode. This round table I was talking about, where I sent out an information frame, and the three of you are set up in the mode to copy unnumbered information frames, and you're set up to copy them so we can have this round table. We're all sending unnumbered frames, and we've all told our TNCs to copy unnumbered frames, and we'll cover that later on. But like I say, even though you're not going to acknowledge that you got it, if you don't get it error-free, you're not going to put it on the screen. So you turn Pass All on. Now it becomes like RIDI. You get little glitches in here, but the mind can fill it in the slots. So that's another time you'd use junk mode, so at least you know what everybody's saying, even if there's some errors. Now you don't care if the wife runs the mixmaster or whatever.
Is Pass All simply a receive function?
Yes.
So what you're sending out is
It still goes through this sequence, yeah. Because there should never be any errors. It's just a short cable from the computer to the TNC. There's another one, TNC parameter called PACLink, P-A-C-L-E-N. In answer to somebody's question earlier about is that 128 bits variable in here, yes, it's defined by a parameter called PACLength. Default, I think, on most TNCs is 128 characters. Now, the way this works is I type away, and if I hit a carriage return, the TNC immediately takes the information, puts it in here, puts the stuff here, does the CRC, or the FCS. It's also called a CRC. Does the FCS, puts the flags on it, and ships it out. So maybe I had 79 characters in here because I typed to the edge of the screen, hit the carriage return. Every time I hit a carriage return, it packetizes the information and sends it out. If I just keep typing away and I never hit carriage return after 128 characters, it will automatically throw it in here, packetize it, ship it out. See? Now, that's fine, but when you're on HF, you really don't want this big long field of 128 characters, because the longer the packet, the longer it takes to get through the radio system, and if you get one noise burst, that packet is gone. So what you do on HF is you say pack length 40, which means as you start typing every 40 characters, he will ship it out. Now you got short little packets, and the odds of them getting through are much better. Now let's say you have well, my problem at home is my HF antenna is in the attic on the second floor, works great, but when the wife turns on the electric blanket, which is about 12 feet below the antenna, it goes click, click, see? If I got one long packet, I'll never get through because that click's going to catch it somewhere in that long packet. So I make a bunch of short ones, that click catches this one, it catches this one, and I just resend them. The noisier the channel, the smaller you want this whole packet to be, so the odds of it getting through without getting a click are much greater.
On HF, the normal length of that frame would be?
It depends on condition. For a lot of noise, then I'll start shortening it down. There's an article about part 8 or something like that where we ran a test, Joe and I ran a test comparing Amtor, and length is what varies this thing. And if you're typing more characters than you have pack length set to, it'll automatically pack it and send it out for you.
A lot of billboards are saying set pack length 255. Is that simply to speed up their
Yeah,
transmission of data?
Yeah, on VHF, we got a nice clean solid signal, FM capture, da-da-da-da. You can run some very long pack lengths. The downside of that is if you send out 6 in a row and each one's got 256 characters, everybody else is sitting there waiting to get a shot at the frequency. That's the downside. You move a lot of frequencies, or a lot of information, but you clog a frequency. That's why you don't find too many BBSs on 145.01. 145.01 is our basic network. You can set on 145.01 and go out to California, down to Arizona, or whatever. Okay? But if you get some people downloading files with these big iframes, it just brings the system right to its knees. So they are on 03 and 05 and that sort of thing for that reason. Because you want to move a lot of information. So you know that if you go up there, you're going to have to contend with BBS stuff. But you wouldn't do that on HF because you'd never get a packet through.
On 01, you're better setting pack length to 128.
Yeah. Yeah. I usually like to set it, at 80 myself. That's just personal preference.
How do you set
Rob?
the pack length?
You type like PACLEN space 80.
Is it the TNC or is it the computer?
TNC. So your computer is just sending those ASCII characters into your TNC. And the TNC is sitting there and counting them. When it gets up to the value you set, he puts all this stuff on here, does the FCS, and sends it out. Or if you hit carriage return before the number of pack length, then you're telling him to do it. Sometimes I'll have pack length set for 40, and it's really getting rough. So I'll type a few carriage return, maybe 10 or 20. I'll force him to send smaller ones, and then when it gets better, then I let it go back to the TNC setting.
Anytime you hit a carriage return, it'll send a packet no matter what the number of characters?
As far as I know, Joe, do you know of any exceptions to that?
No.
No, I think it's pretty much of a rule.
So if you keep typing and it wraps without putting a carriage return, then that's how you can get longer. I take it.
Run that by me again.
Well, that means that, if you hit a carriage return at the end of every line on your CRT, you'll never get a packet over 80. Unless you use auto wrap on your...
Yes.
Okay.
Yeah.
So then you just keep typing until it fills it up.
Yeah. See, one of the mistakes some people make is they will set pack length to 80 and they just keep typing, saying, well, every 80th character is sending it out. The problem is the poor guy at the other end, if he doesn't have wrap on, he gets all screwed up because the fact that he sent a packet, he didn't put a carriage return in there. If you hit the carriage return, it puts it into that information field. So you got the data, 80 characters, and a carriage return. Okay? So it formats real nicely on the other guy's screen. But if you have pack length set to 80 and you're just typing away and letting it do it automatically, there's no carriage return in here. So this poor guy at the other thing, he's going over here, and if he doesn't have wraparound, it's sitting here at the end of the screen just going like that. So keep that in mind. Automatic packeting does not put the carriage return in there for you. Les?
Bill, you're going in on 2 meters, example, you're setting at 128. And you want to go out on 20 meters or HF.
Mm-hmm.
Should those be the same length?
No. The question is when you're going into a gateway where, like we were doing, where you go in 2 and go out on the other end, if you have 128 characters, pack length on 2, and now it's going on out on HF, you don't want characters that long. The node automatically takes care of that. Not only does it buffer, because we're up here at 1200 on 2 meters, and going out on HF at 300, not only does it buffer while it changes the speed, the sysop tells that node how to break it up. Dave has his pack length set to 30. We were sitting here probably at 80 or 128. 128. So his node on HF was breaking it down into smaller packets and sending it out. Any other questions? Okay, let's go ahead and look inside this field here. Just want to flip over. Okay. I stole this, by the way, out of the ARRL handbook. Give them credit. Okay, we're taking this field and we're expanding it out. As the packet goes out, the receiving TNC sees this sequence of characters and he synchronizes it to it. If he doesn't see that, we've already got errors. That's why we don't need to include it in this FCS, because it's a known pattern. If it isn't there, we've already got errors. He sees that. He knows, following this, what the structure of all these fields are. Here we have the destination, the to address, K8KA space SSID. SSID is secondary station ID. And it's a number from 1 to 15. See, we logged into WG0N-7. Earlier here when we talked to the tanker, what the SSID allows you to do is to run multiple functions with one station or multiple stations with the same call. Now, if they were all WG0N, and we said connect to WG0N, we'd have 3 stations coming up, and that'd be chaos. So his node is -7. If I say connect to WG0N-7, his node answers us. And then we said connect to the tanker. If I want to connect to his mailbox, I would have said connect to WG0N-1. And then his mailbox would have responded. If I want to connect to his keyboard to have it come up on his display, I'd have said connect to WG0N.
So that number is the actual time frame in the virtual channel.
Yes, you could call it that too. Part of the virtual channel, because it is. Because I could set up a one link to -7, and then tell -7 to connect to the tanker, like we did. I could set up another call to -1 and say, "Hi, Dave, we're using your BBS." And then I could set up a third channel to his keyboard and say, "Oh, there you are, Dave. I left a message in your box. In fact, I'm doing it now. And by the way, I'm connecting to the tanker. I got 3 channels, all going to the same station, but different functions." Or, like W0TX, we have W0TX-7, which is our gateway to 20 meters. And we have another station located at the Museum of Natural History that is W0TX-2. So when I come up, I got to say -7 for that node or -2 for the other node. They're totally separate stations. So it allows you to do multiple things under the same call.
What does -2 connect to?
Well, it's another node, and then you do whatever you want with it. It's just a different node, a different station, a different location. TX...
1 meters or?
No, it's just a straight 2-meter node. It's just part of the 01 network. Where -7 gets you out of our 2-meter network onto 20 meters. Okay. And these dash numbers can be whatever you want. Okay, but it allows you to run multiple stations, and yet they're totally separate calls, so to speak, or multiple functions within one station. Here's what we were looking for with our interference, the source address. We want to know who this guy was. Those you know are familiar with the packet network. It was DEN 450. He was just tearing us up. Here's the source, KE3Z /SSID. Now, if you want to break this down, here's that ASCII character for K. Remember our 2, 3, 4, 5, 6, 7, 8 bits, 7 bits plus parity. Here's what's called the repeater. In other words, KE3Z sent the packet to K8KA via this digital repeater that we'll talk about later on. And a repeater can have an SSID. It's got a special bit in here called has been repeated. What that means is, let's say I want to connect to Joe, but we're going to go through 2 digital repeaters. My packet goes to digital repeater number 1. He sees that that is a 0. So he makes it a 1. The address, by the way, would be this call and then the second call. The first repeater, second repeater. He would change that bit at the end of the SSID frame to a 1 and then send it. The second repeater would see, okay, that's from here to here via this guy and via me. Has this guy already had it? He says, oh, there's a 1 in there. That means he's already sent it. I need to back up on that. I'm ahead of myself.
Right.
Well, when this station first sends it, this repeater hears it, the second repeater hears it. The second repeater looks in and he sees that the bit is 0. So he knows the first repeater hasn't sent it out yet. So he's going to ignore it. Make sense? The first repeater now retransmits it. The second repeater hears it again and says, oh, I see that the bit is a 1, so that means it's coming from him. My bit is a 0, so I haven't had that one yet. So I pull it in, make that a 1, and send it out. Now the first repeater, he hears it again, because repeaters hear each other, but he sees that that is set to a 1, so he doesn't pull it in, he throws it away. It's a special bit that the repeaters use to determine whether they should repeat it or not.
Do the repeaters do error checking too, or is it just
Yes.
on the other end of it?
Yes, if that frame, and this causes a problem, and we're going to get into this when we describe the network, but anywhere along that chain, if there's an error, it dies at that point. And this is a very important concept, and we're going to cover it in detail. Why you never use a node as a digi-repeater is the basic thing. We're going to cover that in detail because it causes problems.
It says here has been repeater. Is that supposed to be repeated?
It's supposed to be repeated.
Oh, okay.
That was an error in the double RL handbook, Les,
Corrected.
because I just photographed that right out of it.
Not the only one. When the node attaches an SSID, how does it select that number?
Okay, in Dave's system that we talked about, the -1 being for the BBS, the -7 being the node dash the keyboard, he sets that up, and then you have to know it. Now all these stations ID, and they give you that information. They tell you what all the SSIDs are, and we'll see that when we get into it.
But when I connect to a node, the receiving station sees my call N0LEQ-15. Now how did the node attach the SSID to it?
Yes, SSIDs are also used when you go through nodes for control purposes, and when we get to the network, we'll explain that, how that works and why they do it. It's the same kind of a principle here. It's to keep things from talking to each other. It's a form of control. I mean, if I connect to a node, and then that node sends out a call, and it has my call, my station's going to think it's for me. So the node, when it sends this information out, puts it at -15, my node, TNC, says, well, I'm at a -0, so I'm going to ignore what's going out. It's that kind of thing. We're going to get into that detail here later on. This is the type of thing we're going to cover when we talk about how to use the network and how does the network work and all that.
The term SSID.
Secondary station identification. Now it's coming up on 9. Do we have any objection if we turn over to Joe and we get into the control field? Because the next slide would be a real good breaking point. Dun, 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 dun. Psst.
Why don't we just break for the night? I mean, break for the week. I mean, we're at that point, really.
You think so?
We don't want to get too heavy into this
Okay.
when everybody has been sitting for a couple hours.
Well, I'll tell you what. Part 13, I think, in the handout there, or part 14, one of those two gets into this. So you might want to read what we talked about tonight and then read that to get into this, because this starts getting heavy in this area. Because we're going to talk about what all this stuff is and how is it used to make sure that a packet got there, that it got there in the right sequence, that it didn't get corrupted, these kinds of things. And this is the hardest thing for people to understand. Next week will be the toughest week of the whole course. Really heavy. And that's why I get Joe, because he's our big bouncer, and if you don't get it, he'll pound it into your head. Besides, he used to teach this stuff commercially anyway, so it's right down his alley. He's used to pounding this stuff in people's heads, right?
Yep. By us.
So don't let him send you to Paris next week, because you're going to be needed here. Question?
Question is kind of a sidebar to the repeater. What is the difference between using V, or spelling out via,
No difference.
or can I use a comma?
Well, you have to say,
I see it repeated on my NCOM inserted a comma there where I had the
Yeah, because that's part of the protocol. Because see, there was, back there in the address field, you know, it knew where everything was, and the comma was put in there basically for you. Your TNC's really doing it. Because there is no comma between those vias in there. So what you do...
repeating through, say, the total of 8 repeaters, would you have to put a V in between?
No. What you would do, just so the TNC knows, you would say connect to W6ABC, V, first call, comma, second call, comma, third call. The commas are just to tell your TNC that this is the end of this address, this is the end of this address. Then when he sends it out, he just has the destination address, source address, and then the various calls, because once he's synced in on the flag characters, he knows that this is a call, this is a call, this is a call. He doesn't need to know with delimiters. So the delimiters are really for us humans to talk to the TNC and that sort of thing.
Going back a frame, the address or the call in the repeater ID would contain just the repeater that's being used at the moment, and if so, where are the repeater calls are stored if this thing multi-hops its way across the country?
Okay, what you have to do, can we back up one? See, what you do is when you set up the path, you have typed, like we were talking about, connect to W6 ABC via repeater 1, via repeater 2, via repeater 3. And the way you do that is you say, in other words, you have to define the path. You have to tell the TNC how to get it there. There is no logic in the TNC as far as routing. So you have defined what you want in here, and then here, here, and here. Now this frame goes out. Maybe this repeater or digipeater and this digipeater hear this. The first digipeater, he sees that he hasn't had this frame yet because there's a 0, so he pulls it in. The second digi here, who happens to be further away, but he heard it too, he looks and he sees, oh, the guy in front of me hasn't put a 1 in there, so therefore I got to ignore it because it's his. So it goes into the buffer of the first digipeater. The first digipeater waits till the frequency is clear. He sends it out after he set a 1 in here.
So
now,
that's why it may be 14 or 21 octets in the address.
Right. Yeah, see, he's going to know by the structure here where the end of it is, and he can work backwards and figure out all these addresses. We don't want to get too deep into that, but the point is, you set up the path. You tell a TNC the route for this packet to go when you first set up the connection. You say connect to W6ABC via digirepeater 1, digirepeater 2. And like I say, that puts the calls in here when it goes out. Now, like we were saying, when it first goes out, all of the has been repeated bits are 0. So each guy looks to see if there's a 0. In other words, this digi here that happened to hear it, he looks to see if the first repeater had put a 1 in there. If he hadn't, he knows that since he's second on the chain and the first one hasn't had it yet, he throws it away. So the first one puts a 1 in there. Then when the frequency is clear, he sends it to the out again. Now the second repeater hears it. Okay. My TNC hears it, but I ignore it because it says it's going to him, not to me. So the second repeater or digipeater hears it. He says, oh, I see 1's in there now, and I see there's a 0 in my place. That means I haven't had this one. Because they don't keep track of these things. It's just store and forward. I put it in here and I ship it out, and I don't remember anything afterwards. So he brings it in, he puts a 1 in his slot, sends it out. Now the first repeater, digipeater, will hear this frame going out from the second one, but he'll see that there's a 1 in there. He'll say, oh, I've already had that one, so I won't buffer it and store it. Does that answer your question?
So when you get to the far end and you want to know the route it took, all you do is just read the octets after 14 in the address.
Right, you can turn on your MCON to whatever level you want, and it will show you all this stuff. That's part of this troubleshooting. You turn it on and you start reading the stuff in here. See, if you're in just the normal connect mode, all you see is what's in here. Then when you start turning on your MCON, which is monitor while you're connected, or your monitor command, which is monitor when you're not connected, you can define how much of this stuff you want to see. The highest level, you should see everything in here. See? Well, when you're normally talking to somebody, you really don't want to see all this stuff, so you just set it up to read this. Question?
I guess I think I understand all that, but the thing that's confusing me here a little bit is the structure of that address portion between 14 and 21 octets. Now you've got the thing that you've shown there, the destination, source, and repeater. Seems to me that you've already accounted for 21 octets right there. How?
Well, this is 1 octet right there.
Oh, I see.
Wait a minute. No, I'm lying. Here's an octet here.
Yeah.
Octet. So you got
There's
7.
There's 7 in the destination, 7 in the source, 7 in the repeaters. That's 21 right there. How do you add on a whole bunch of other repeaters in there without going over 21?
You do. It's 21 is not the maximum.
That's an interesting point. You know, this is the 3rd class, and it's the first time anybody's even brought that up. I never counted them.
That's 3 octets right there.
No, that's
Using all 8 repeaters, you get 7 bytes.
no. This is an ASCII K. That's an ASCII 8. That's an ASCII K.
Yeah.
ASCII A, ASCII space, and then the SSID is 1 octet, 8 bits, and the breakout of the SSID is this. And the reason he can have a variable number of via addresses is because he sets in the SSID, he sets the last via address of the SSID bit number 8201, and it's 0 on all the others. That's how he can tell where the end of this is and where the control and information.
Okay, but you're not limited just to 21
No.
octets.
You're limited to 8 fields here.
You're limited to 7.
Okay.
We'll have to look that up. I don't know. I've never paid any attention to it.
No, that's
fine. Well, as long as
Since-
you don't have to send out another packet or something
Yeah.
with those different things in it. You can just add that all goes up to 9 the destination, the source, and up to 9 repeaters can all be put in the address portion of that.
Right. Yeah, that's an error. I'm not sure. I'll have to look that up. Joe will answer that next week.
Yeah, that's true. In other words, this doesn't mean that we're limited to 21 octets. It's going to be 14 octets if we don't have a via. It's going to be 21 or more if you have a via.
Yeah, I'm not sure why. I have to look that up because this slide, like I say, I just took a picture of this thing right out of the handbook, and I didn't even look at the fine stuff there. So that's an interesting question. Any other?
If I hook up to a node, not a bit repeater, do I have to supply the path, or does the node supply the path?
Well, that's about an hour dissertation in the network section. It depends on how you're doing it and the type of node. DNets and NetROMs will try to get you there direct. They'll try alternate routes. Remember we had that little example at the beginning about alternate routing. That's automatic with NetROMs and DNets. When it's what they call CAMs, which is what this is, and this is what we use, by the way, up there in the hill to talk to the tanker, this little guy right here. That you got to tell how to get there. It doesn't know. So we'll cover all that and show you how to do it all.
Well, it's like two ways of operating, isn't it? You're going to a node, doesn't it do kind of like what you...
Depending upon which node it is.
The routing, the vias.
Depending upon which type of node it is, Certain nodes do it automatically, certain other ones don't. You have to do it. And there's pros and cons to both systems. And the system on 01 is mostly the automatic routing type. Theoretically, I can say, connect me to Salt Lake City, and it'll get me there one of 2 or 3 different paths, this sort of thing. But on these type of nodes here, they work differently, and you have to tell them how to get there. And there's advantages to both systems. And like I say, we'll get in deep, probably week after next, we'll start into that stuff. And we'll have a lot of examples here. We'll be demonstrating all this stuff. So you won't be looking just at slides starting next week. Any other questions? Well, I guess we need to go home and see if Rocky Flats is out of 4,000 jobs, huh?